welcome back at C Squared. In this lesson we're going to talk about polygons and we're going to talk about the angles of polygons. First of all, let's see what a polygon is. And I said here, two-dimensional shape with at least three sides. A triangle is a polygon, and this is the triangle. Quadrilateral, four sides, polygon. Pentagon, five sides, hexagon. So you have these four convex polygon here. So this is the polygon we're going to talk about, convex polygons, and you see four of them here. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. Like in this case, you notice right here DF. This is a diagonal. Obviously there is no diagonal for a triangle. But also, if you notice here, we have two diagonals, HI and HK. In this hexagon we have three diagonals, MO, MP and MQ. All these diagonals that you see here are starting from a vertex to the other vertices, the same vertex, D, F, for more, and then H, J, HK and MO, MP, MQ. Obviously we have more diagonals in case you ask yourself if you have more. Yes, we can have EG, we can have IL and so on. But in this case I'm gonna start from one vertex. Why? Because then I can go to this next part of the lesson, and as you know, the sum of the interior angle of a triangle is 180. But then if we look to a quadrilateral four-side polygon, this diagonal creates two triangles, each one being 180. So the sum of the interior angle measure of a quadrilateral is 360, 180 plus 180. Very similar we can do for a pentagon. We have three triangles. You see these two diagonals form three triangles, and if we add these three 180 degree, that tells us the sum of the interior angle measure of this pentagon is 540. Very similar for an hexagon, where we have four triangle, and that means if we add these four 180 degree, we get 720. So the sum of the interior angle measure of this hexagon is 720. Okay, and you notice here beside this down here in this table, beside the triangle which we talk, only one, quadrilateral two triangles, pentagon three triangles, and hexagon four triangle, I add three more shapes. A heptagon which has seven sides, that will have five triangles. An octagon which has eight sides, we're going to have six triangles, and a nonagon is going to have seven triangles. If I extend this table, I'm going to get exactly what we had on the first part of the previous slide. So a triangle 180, two triangle 360, three triangle, which is, if you remember, was the pentagon, 540, 720, 900, 1080 for an octagon, and now for a nonagon 1260. But we don't want to do this table in order to find the sum of the interior angle measure of a polygon with 217 sides, let's say. We can use very simple this formula. If a polygon has n sides, then the sum of the measure of the interior angle is going to be n minus 2 times 180. So if you have 217 sides, just plug it in. Let's see an example here. And in this example, we need to find the measure of each interior angle of the polygon below. The first thing you want to look is how many sides you have. 1, 2, 3, 4, 5. So we have 5 sides. And if we use the formula I just said before, n minus 2 times 180, I'm going to end up with what? 5 minus 2 times 180. Using the order operation, obviously we're going to do 5 minus 2 first. That is 3 times 180, and that will be 540. Yes, this pentagon, right, n equals 5. 5 sides, that means a pentagon. The sum of the interior angle is 540. This one was in the previous slide, one of the choice. But now what can we do? Now we can write this fact that the measure of angle A the first one, right, plus the measure of angle B, plus the measure of angle C, plus the measure of angle D, plus the measure of angle E, the 5 angles of this pentagon, right? We have 5 angles. The sum of these 5 angles is 540. And now we're going to replace this measurement with the expression or the value we have. Angle A is 2x plus 11. Angle B is 3x minus 15. Angle C is 2x. Angle D, we have a value 124 degrees, and angle E is 3x. So I replace, and that will be 540. From geometry, you end up with an algebraic equation, this one. And what can we do here? We can combine the like terms, in this case the x's, and you notice we have 2x, 3x, 2x, 3x, that will be 10x. And then we have 11 minus 15 plus 124, that will be 120 equals 540. I'm going to subtract 120 on each side. And we have 10x equals 420. Divide by 10, because you're going to cancel these 10. And we end up with x equals 42. But again, this is just the first part of this problem, because we have to find the measure of each interior angle. So we're gonna have to go back and plug it in. What do I mean? Let's take a look. Measure of angle A is 2x plus 11, so you're gonna have 2 times 42 plus 11. 2 times 42 is 84 plus 11. That will be 95. What about angle B? Very similar approach. Angle B, it's 3x minus 15. So 3 times 42 minus 15. 3 times 42, that is 126. Minus 15, we're going to end up with 111 degrees. Angle C. The measure of angle C is 2x, so we're going to have 2 times 42, and that will be 84. Angle D, we don't have to do anything because we have it. It's 124. I'm just going to copy. And the last one, angle E, is 3x. 3 times 42. And that will be 126 degrees. And that's it for this problem. These are the measures of the interior angles of this polygon. Regular polygons is my next topic in this lesson. Regular polygons have all sides and all angles equals or congruent, if you want to call them like that. And you see here 4 regular polygons. The first one, a triangle, all sides equal, all angle equals. You may say this is the equilateral triangle. That's correct. This is the square. We have a name for this regular polygon with 4 sides and 4 congruent angles. This is the square. Now this is a regular pentagon, I'm sorry. A regular polygon with 5 sides is called pentagon, and this is an hexagon. This is the polygon that has 6 congruent sides, regular hexagon, and 6 congruent angles. For finding the measure of one interior angle, you have to divide the sum of the measure of the interior angles by the number of angles. If you notice, that's what I said here. So that will give us one angle. So for example, here you remember a triangle 180, divide by the number of angles, 3, that tells us this is 60, which we know it, equilateral triangle. 360 is the quadrilateral divided by the number of angles, which is 4. That tells us this is 90, which you notice is a box here. What about this one? 540, the sum of the interior angles of a pentagon divided by 5. So that will be 108. Every single angle here is 108. And the last one in my slide here is the regular hexagon. 720 is the sum of the measure of the interior angle of a hexagon divided by 6 angles, because you have 6. That tells us every single angle is 120 degrees. So obviously there is a way to do to find the measure of an interior angle of an inside regular polygon. And this right here, this is the formula you can use for finding the measure of one interior angle of an inside regular polygon. So let's take a look to this example where we need to find the measure of each interior angle. So this one, for example, angle 1, and every single angle here is going to be the same, so we just need to find one. How are we going to do that? Remember, we have that formula, measure of angle, I'm going to call it 1, like I said, is what? N minus 2 times 180. That is the sum of the whole interior angles divided by how many angles? N. Okay, so now we need to figure out what N is. N is the number of sides, so we're just going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a regular polygon of 12 sides. It's called the dodecagon. So now we're going to plug these 12 for N, and let's see what we get. Okay, so obviously we have here 12 minus 2 times 180 divided by 12. 12 minus 2 is the first thing you're going to do, which is 10 times 180 divided by 12. So if you don't have a calculator, or you cannot use a calculator, obviously you may want to simplify. Well, I'm going to use a calculator here, and I'm going to do 10 times 180, and then I'm going to divide by 12. 150 degrees, that is the measure of angle 1. Like I said, if you don't have a calculator, or you cannot use a calculator, it's not super complicated to simplify here. For example, 12 and 180, they have a common factor of 6, so that will be 12 divided by 6, 2. 180 divided by 6 is 30. And then 2 goes in 30 15 times. So you notice we have 10 times 15, which is 150. Okay, so every single angle here is 150 degrees. But let's take a look to this example. In this example, we are told that the measure of an interior angle of a regular polygon is 144, and we need to find the number of sides. So this problem is backwards. We know an angle, which I'm going to call it 1, like in the previous example. Can we find how many sides? So remember, one interior angle, angle 1 in this case, is going to be what? N minus 2 times 180 divided by N. And I know this angle 1, that is 144. So I'm going to replace it. And the difference now is that we have an equation in N. We need to find N. One way to do it is by simply multiplying by N like this. Why you can do that? Because N cannot be 0. Don't forget to do the same thing on the other side. So we end up here with 144N on the left side, and on the right side we have 180 times N. So that will be 180N, and 180 times 2, that is 360, but don't forget it's a minus 360. And the easiest way to solve this equation is to subtract 180 N on both sides. So we cancel out this. Don't forget to do that here. And we have 144n minus 180, and that is negative 36n equals negative 360. Divide by negative 36, because you want to get rid of the negative 36. Don't forget to do the same thing on the other side. And we have n equals 10. The polygon, the regular polygon for which the interior angle is 144 degrees, is the polygon that has 10 sides. Decagon is the name of that polygon. Let's take a look to exterior angle. This is another type of angles that you can work when you have a polygon, like these angles here. You notice we have two hexagons. This is a regular hexagon. This is not a regular hexagon, but either one has 6 exterior angle, right? In this case, when you have a regular polygon like this one, these angles are congruent. All these angles are congruent. When the polygon is not the regular polygon, obviously these angles are different. But we have this theorem. The sum of the exterior angles measured of a convex polygon is 360. So either way, for the first picture, the one on the left, this one, or the one on the right, the sum of the measure of the exterior angle is 360. However, when you have a regular polygon, we have a better way to find one exterior angle, or in fact all of them. What is that? 360 divided by n. Why? Because remember, these angles are congruent. So let's see how this works in this problem. So we're looking in this problem, we are asked to find the value of x. Okay, we're looking here. It really doesn't matter, but this is a hexagon, right? 1, 2, 3, 4, 5, 6. Yeah, but what do we know? The sum of the exterior angles measured is 360. So you can start with anything you want. Let's say you start with x minus 2. This guy plus 2x plus 9, the second angle, plus 78 plus the next angle is 52 plus the next angle x minus 3 plus the last angle, right, 2x plus 4. The sum of the measure of the exterior angle of a polygon is 360 degrees. So we have an equation here. So how we solve this equation? Again, we're looking, combine like terms, x, 2x, that is 3x, 4x, and another 2x. That means we have a total of 6x's. Now we have here negative 2 plus 9 plus 78 plus 52 minus 3 plus 4. I'm going to use a calculator for this, but obviously it can be done without calculator. Okay. I end up with 144 equals 360. Let me double check one more time. Negative 2 plus 9 plus 78 plus 52 minus 3 plus 4. Oh, I'm so sorry. I think I got 138. And you know what? I'm going to try one more time just to be sure I have the correct answer. I apologize for that. One more time. Negative 2 plus 9 plus 78 plus 52 minus 3 plus 4. Yeah, it's 138. And now we're gonna subtract 138 on each side because we want to get rid of this 138. And 360 minus 138 is 222. And the last step for finding x, which is the goal in this problem, is to divide by 6 to get rid of this 6. And that will be 37. X is 37. And that's it for this problem, ladies and gentlemen. Now let's take a look to this example where we need to find the measure of each exterior angle of each regular polygon. We have two problems in here. On the first one, you have a pentagon. If you remember, pentagon means the polygon that has 5 sides. How much is the measure of an exterior angle? If you remember, the formula is 360 divided by n. That is the measure of an exterior angle. So in this case, we have 360 divided by 5. So the measure of this exterior angle for this pentagon, regular polygon, be careful, this formula works only if we have a regular polygon, it's going to be 72 degrees. What about the next problem, number B? That one we have a 15 gone. We have a 15 sides polygon. So the same formula, the measure of an exterior angle will be 360 divided by n. In this case we have 360 divided by 15. Again, this one can be simplified if you don't have a calculator or if you cannot use a calculator. I'm going to use a calculator here, and we have 360 divided by 15. That will be 24 degrees for this polygon that has 15 sides. Now let's take a look to this example. In this example, if you notice, what is given to us is the fact that we have a regular polygon and the exterior angle is 12. Can we find out how many sides we have? The answer is yes. We're going to use the same formula. The measure of an exterior angle is 360 divided by n. Now, if you notice, we know the exterior angle in this case is how much? 12 degrees. So that's the thing I'm going to replace here. 12 equals 360 over n. We have an equation where you need to find n. I will do something very similar. I will multiply by n first. Why? To get rid of this n. Don't forget to multiply by n the other side. So we have here 12n equals 360. And the last step is divide by 12. So we end up with n equals 360 divided by 12. That will be 30. And this 30 here means we have this polygon for which this regular polygon for which the exterior angle is 12 degrees has 30 sides. Let's take a look now to some other problem that involve polygons, like in this case here. If you notice, we have two regular polygons. We have an hexagon, this one, and a quadrilateral or square in this case. We need to find this measure of angle 1. For finding this measure of angle 1, we're going to need to find this angle. I'm going to call it 2. And these angles, which I'm going to call it 3. And you notice the sum of the measure of these 3 angles is going to be 360. But how are we going to find angle 2? Measure of angle 2. That is an interior angle for that hexagon. So I'm going to use the formula that we had before, n minus 2 times 180 over n. In this case, n is 6. Yes, we have an hexagon here. 1, 2, 3, 4, 5, 6 sides. So this becomes 6 minus 2 times 180 over n, which is 6. 6 minus 2 is 4. 4 times 180 over 6. So that will be 120 degrees. That is the measure of angle 2. Very similar, we're going to do angle 3. The same formula. N minus 2 times 180 divided by n. The only difference now, how much is n? 1, 2, 3, 4. N is 4. It's a quadrilateral. So this is going to be 4 minus 2 times 180 over 4. 4 minus 2 is 2. 2 times 180 divide by 4, and that will be nothing else than 90 degrees. And now we can move and find the measure of angle 1. Why? Because, like I said before, measure of angle 1 plus measure of angle 2 plus the measure of angle 3, these three angles you see here, 1, 2, and 3, you go around this point, so that will be 360 degrees. So we're going to have measure of angle 1, the one we need to find out, plus measure of angle 2, which is 120, plus the measure of angle 3, which is 90 degrees, is 360. And then we can combine 120 and 90, and that will be 210. That is equals 360. The last step is to subtract 210, and we end up with measure of angle 1 is 150 degrees. And that's it for this problem. Very similar this problem with this one. Unfortunately, we're going to have to do a little bit more work, but we can start with some easy steps. For example, I can start with this angle 1 here. That angle 1 you see there is an exterior angle for what? For this polygon that has 1, 2, 3, 4, 5. This is a regular polygon, by the way. So how are we going to find that? It's just simply 360 divide by n. In this case, n, like I said, is 5 because we have 5 sides. So we have 360 divide by 5, and that will be 72 degrees. So that is the measure of angle 1. Okay, do we have another angle that we can finish fast? Yes, the answer is angle 3, this one. This one is an exterior angle for this polygon that has 4 sides, quadrilateral. We're going to use the same formula. The measure of angle 3 is going to be 360 over n, but n in this case is 4. So we have 360 divided by 4. That will be 90 degrees. That is the measure of angle 3. So these two angles, easy exterior angles. So that's it. What about angle 4? We cannot do anything for angle 4, but we can do something for angle 2. Exactly what we did in the previous problem. We're going to have to find the measure of this angle. And this angle, if you remember, is a pentagon. We have 5 sides, n minus 2 times 180. Let me do that. Let me call it angle 5, this one. The measure of angle 5 is going to be n minus 2 times 180 over n. This is an interior angle of that polygon, and n is 5 pentagon. So we're going to have 5 minus 2 times 180 divided by 5. 5 minus 2 is 3. 3 times 180 divided by 5. If we do that math, we're going to end up with 108 degrees. This is not an angle that we're looking for. What about, yeah, let me go back. What about this angle here? I think this one is going to be a very easy one. This is a triangle, equilateral triangle. So this angle 6, I'm going to call it here, is going to be nothing else than 60 degrees. You can use the same formula and you replace with n equals 3. So we're going to have 3 minus 2 times 180 over 3. So we're going to have 1 times 180 divided by 3, and that will be 60 degrees. And we have one more. We have this angle here, which again is not super complicated. That is going to be 90 degrees. Is this square here, but we can use the same thing. I'm going to be consistent and show the same math. The measure of angle 7, how I call it, it's going to be the same story. N minus 2 times 180 over n being 4 here because it's a 4-sided polygon. So we're going to have 4 minus 2 times 180 divided by 4. We are going to have here 2 times 180 divided by 4, and that will be 90 degrees. Now we can really go and find this angle 2 we have here, because angle 2 plus angle 5, which is 108, plus angle 6, which is 60 degrees. Let me be sure this is 8 here. Angle 7, that is 90 degrees. So the sum of these 4 angles is going to be, if you set 360, that is correct. Why? Because we're going around this vertex. Now then we have measure of angle 2 plus, and let's add these 3 numbers. I'm going to have 108 plus 60 plus 90, that will be 258 equals 360. Subtract 258 from both sides. And we end up with 102 degrees. Okay, so we finish angle 2. We have one more. We have angle 4, which is right here, right? And look at this polygon. This is a polygon with 4 sides. Okay, so what do we know about this polygon? The sum of the interior angle is 360. This is one polygon that probably you want to remember. You're gonna need it more and more in your geometry classes. 360 degree for a quadrilateral. So we're gonna have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 360. Angle 1, 72. Angle 2 is 102, the one we found out just a minute ago. Angle 3 is 90 degree. And angle 4 is the last one you need to find out. So very similar, we're going to add these 3 numbers, 72 plus 102 plus 90, that will be 264 plus the measure of angle 4 equals 360. So the last thing obviously is to subtract 364 from 360, I'm sorry. So we're gonna have 360 minus 264. That will be 96 degrees. And that's it for this problem. A longer problem, but you see, you need to know about exterior and interior angles of a polygon. And my last problem in this lesson will be about this type of situation. You notice here we need to find the angle 1, which is inside of this polygon, okay, and here angle 1 is outside. But still, let's go back here, and for that reason the first thing I want to do is to find the measure of this angle. And this is a regular polygon with 1, 2, 3, 4, 5, 6. So the measure of that angles 2, I'm gonna call it like that, will be what? N minus 2 times 180 divided by n, where n is 6. Let me put that here. N is 6. So if we replace that, what do we get? 6 minus 2, that is 4 times 180 over 6. I move a little bit faster here, but we did this problem several times. Now we'll end up with 120 degrees. This angle 2 is 20 degrees. And this angle here is going to be the same with this angle 1. Why? Because this is an isosceles triangle. These two sides are equal. So I'm going to have the measure of angle 1 plus the measure of angle 1 plus that angle 2, which is 120, equals 180, because that is a triangle. So we're going to have twice the measure of angle 1 plus 120 equals 180. I'm going to subtract 120 on each side. So we get 180 minus 120 is 60 degrees, and the measure of angle 1 is 30 degrees. Okay, so don't forget, this is an isosceles triangle. Very easy to find the base angle, how they are called. What about the last problem? How do I'm going to find this angle? Very similar. If you take a look, this angle 2 here, or let me call it 3, and these angles 3 here, they are the same. They are exterior angle for this polygon with 6 sides. So how do I find that? The measure of angles 3 will gonna be 360 divided by how many sides we have? 6, right? And in this case, it's gonna be 360 divided by 6. Like I said, it's gonna be 60 degrees. Okay, and now we can find angle 1, because this is a triangle. This one here is a triangle, and the sum of the interior angle of a triangle, the sum of the measure of interior angles of a triangle is 180. So that's the thing I'm going to write. The measure of angle 1 plus the measure of angle 3 plus the measure of angle 3, the sum of the measure of these 3 interior angles of that triangle is 180. And we have the measure of angle 1 plus 60 plus 60, the two angles that are the same, equals 180. The measure of angle 1 plus 120, right? 60 plus 60 equals 180. Subtract 120, and we have the measure of angle 1 equals 60 degrees. And by the way, this is a kind of a special triangle. It's an equilateral triangle, the red triangle you see in the picture. And that's it for today. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.